Alright guys, how's it going? We're going to get into our last note today of quadratics. It's going to be the same thing. I'm going to give you guys the rest of the week. Friday will be your assignment, and next week we are going to start on my favorite, which is triangles. And triangles are essentially our last unit. And then, yeah, so sweet. One thing I'm going to go over, yesterday I did tell you for the word problem that I'm not going to have a number in front. So what I mean by that is, I did say I'm not going to have a number here. So what I'm going to do is, because I was looking through all the questions and all of them do have numbers out front based on the information that we need from it. So I'm actually going to do the number, but I'm going to tell you what to factor as well. Okay, so I'll do it in these examples here, but also in your practice problems, I'm going to give you this equation just because if you remember, we need to get our y-intercept from it. Remember yesterday when I was like, oh, our y-intercept's this. Oh, that doesn't work because I had common factored it first. Okay, hopefully that'll make more sense in a bit. So, one thing that you guys might want to pull up is the factoring sheet that I gave you, the flow chart if needed, and also yesterday's note, like lesson 13, because each section tells you what you have to do, right? So pretty much what you're going to do when you have a word problem is you're going to do three main things. You're going to look at your equation, which is here. I am tapping on it, but it's not highlighting. Let's do this. Okay, your main equation, which is here. And then you need to do three main things with it. You need to factor it, you need to find the axis of symmetry, and then calculate the vertex. And once you do those three, then you should be able to answer these questions. So before we even necessarily look at the question, we're just going to look at the equation that it gives us. We're going to graph it. And then we're just going to answer the questions based off our graph. Okay, so factor to find the zeros, calculate the axis of symmetry, find the vertex using the x value from the axis of symmetry. So we have the equation. Oops. This looks really different today. I don't know if I'm just zoomed out more. Anyways. Okay. H is equal to negative 2t squared plus 28t minus 90. Okay, so it says factor to find the zeros. Okay, so we need to factor first. So this is where I'm telling you, even though we have this negative 2 out front, when it comes to your question, I'm going to make sure that you don't have that. Okay, like I will make sure, like if the original question has that number there for my A spot, I'll say factor this. Like I'll give you the reduced whatever. Okay, H is equal to negative 2 bracket t squared minus, because now I'm taking out a negative 2, right? This is a common factor, so I'm doing 28 divided by negative 2, and that is negative 14. Okay, this is why we did that practice earlier. Then we have negative 90. Negative 90 divided by negative 2 is positive 45. Okay, so we are going to factor, all right, we're factoring this. Okay, we're not using that 2. That 2's gone now. It's just a common factor. It's like we're just reducing it. We could try to factor it with that 2 in front, but it takes a lot more work, and we're not doing that. Yeah. So I need two numbers that add to this and multiply to this. So this is where I say get your factor sheet out. Okay, so two numbers that multiply to 45. Remember, it's positive 45. So what does that mean? So if you use your chart, you're also going to find out that both numbers need to be negative because my A, or negative 14, is negative. Okay? So what are my factors for 45? Obviously, I've got 1 and 45. One sec. There we go. Yeah, so if we're using it, the B term is negative, and the C term is positive. So both terms are negative. That's what it says in the chart. I know I don't have it up, but you can follow along yourself. I do have that factor sheet. I can't seem to find it. There we go. Found it. Okay, 45. 45, 45, 45. 1 by 45, 3 by 15, and 5 by 9. So, I know both of them are negative. I've got negative 1, negative 45. I've got negative 3 and negative 15. And I've got negative 5 and negative 9. Okay, so we got that. Now we need two things that add to negative 14. So, negative 1 plus negative 45 would be negative 46, so that's not it. Negative 3 minus, or plus negative 15 is negative 18, so that's not it. Process of elimination, negative 5 minus 9, put in your calculator, negative 14. So these are our two numbers. Okay, so we're still factoring them. So we have x minus 5, x minus 9. Okay? We have to take them out. That means x is equal to 5, x is equal to 9. So we're gonna graph those. Okay? We factored the zeros. We factored to find the zeros. These are my zeros right here. X is 5, x is 9. So we're going to graph those. Remember, this is my x. Oh, yeah. Okay, so see how I have x's? In this case, I have t's. So in this equation, we're representing it by t's. So that means even though this is my x-axis, in this equation, we're representing it by a t. Okay, so I can do that in a bracket, but this is my t. So, 5 and 9. Perfect. Okay. Calculate the axis of symmetry. Let's do another color. So how do we calculate the axis of symmetry? I don't know. Oh, I can't remove it. So axis of symmetry is we take these two numbers, add them up, divide by 2. So axis of symmetry, we have 9 plus 5. You could do 5 plus 9, it doesn't matter. 9 plus 5 is 14. 14 divided by 2 is 7. Well, that was easy. So, again, you don't have to use a ruler, but we know that this is our axis of symmetry. Remember, symmetry. Symmetry means the same. So, I'm just going to zoom it out. That means if I were to put a mirror here, Oops, let me move that over just a tad. Close enough. Okay, so we know that the parabola is going to go through that point somewhere. Okay, find the vertex. Do you guys remember how to find the vertex? No? Look at your notes. Okay. Using the x value from the axis of symmetry. So, I can't remember what color I used. It looks the same. We take our original value, our original equation. We plug this. Now, it says my x value, but remember in this equation we're representing it by t. We're going to plug this in there. So, my original equation, sorry, let's do this. And so, h is equal to -2, 7 squared, plus 28, 7, minus 90. Okay, remember BEDMAS. Exponents first. Right? We have to do this first. So, 7 squared, 7 times 7 is 49. Times 7 minus 90. If you guys can do this in less steps, go for it. Now what I'm going to do is I'm going to multiply those two together and these two together at the same time because it's separated by the plus. So that's okay. -2 times 49. 2 negative, oops. Yeah. -98. 28 times 7, 196, minus 90. So I'm going to plug that into the calculator. 98, -98 plus 196, minus 90 is 8. All that for 8. Okay, see how this is an H, not a Y this time? That means this is represented by H, which is usually our Y. And what is that number? We know it's on the axis of symmetry, so it's right here. If you don't remember that, review the last note. So, let's go back to the original question. The path of a paper plane, airplane, is given by this equation that we've already used, where t is the time in seconds. Okay, so now we're given some units. We know that t is being represented instead of x, so this is time in seconds. And h is the height in feet. So, find the maximum height of the airplane. Hint, find the vertex and find the maximum height. Sketch the graph to help you. So pretty much we've already put in all the information. Here is our graph. I know that doesn't look exactly like parabola, but whatever. So what's the maximum height? Well, this is the highest point right here. So the maximum height is 8 feet. So, sketch the graph. What's the maximum height? 8 feet. That's the highest it goes. Yeah. When does the airplane reach the maximum height? So, we're going to go over here. I'm at the maximum height. When? When is a value of time? So I want to know at what time, at how many seconds it reaches that height. It's 7 seconds. That's all you have to do. So some of you might say, well, it starts here. Well, it doesn't necessarily start there. It's just we can't see the rest of the graph. Okay, we're only looking at the tip of it. If you were to go all the way down, as you remember, because I'm sure all you do, this is my y-intercept, right? So that's negative 90, like that's way down there. And then just for good measure, where is it? Let's throw this bad boy into Desmos. So I'm just going to keep, with respect to Desmos, I'm just going to keep it as X and Y. I don't know if it can read other letters, to be honest. Plus 28t. So X minus 90. If you take a look, here's our parabola upside down, which is right because it's negative. Here's our vertex, which is 7, 8, which is what we determined. Our y-axis is our height, our x-axis is our time, and our two intercepts are 5 and 9. And if you were to look at this, so as I said, remember, picture it as like the ground. So like, I don't know where this paper plane came from, but it came from 90 feet below the ground, I guess. Or, another way to think of it as, I'm going to do it on the other one because I can draw here. Is what we did is that we had a person start from here, and we're like, okay, go. And then it ran. He ran. He ran, and then at the 5-second mark, he threw the plane. Oops, I have to do that a little bit better. And the plane went, and then it reached this height, and then it started coming back downwards. And it hit the ground at 9 seconds, back at the 9 seconds. And that's what that means. I hope that makes sense. Okay? So, essentially what you do is when you're given the equation, factor it, find the axis of symmetry, and do the vertex. And then you can plot it, and then you can answer the questions. I just find it easier that way. If you're still having a hard time, obviously, like, let me know. Okay, a football player kicks a ball off a football tee. The height of the ball, h, blah, blah, blah. Okay, we're going to ignore that for now. So our equation is h is equal to negative 5t squared plus 10t. Okay, what's the first thing we do? I think it says factor. Factor it. So, not going to use all the colors this time. I'm going to make that a little bit thicker. I'm going to go with blue. Okay. So as you guys see, there's no C value. So technically it's plus 0. Okay. If you guys want to throw that in there just for good measure to help you see different things, go for it. So we need to factor it. So the first thing I'm going to do is common factor, meaning I'm going to take out this guy right here, this negative 5. Again, I'm not going to get you guys to do that. When it comes to the factoring part, I'm going to just show you what the equation is. So that means our new equation is going to read negative 5 bracket t squared. 10 divided by negative 5 is negative 2t. And then plus 0. Okay, some of you might need it, some of you might not. That's okay. So this is what we're factoring right here. So remember, two numbers that add to this and multiply to this. Well, that's confusing. Because, well, if you think about it, multiply to 0. Anything times 0 is 0. So wouldn't that make it easier for us to find our thing? Because it's going to be what multiplies to -2. Or sorry, adds to -2. Multiplies to 0. I lied to you. Well, anything times 0 is 0. So if I do -2 and 0, these are zeros, by the way, not O's. That's 0. And if I do -2 plus 0, that gives me -2. So those have got to be our factors. I hope that makes sense, guys. I know that's a little confusing, but because anything times 0 is 0, it's got to be 0, and we know it has to add to -2. -2 plus 0, -2. Right? Yeah. Okay. So these are our numbers. That's kind of easy. So we're going to have x minus 2, and I'm just going to do x plus 0 because it's 0. So let's take it out. So these are our roots. So let's plot them. This is one. This is the other. Okay. So we factored. What's our next step? Axis of symmetry. You're going to do 2 plus 0 divided by 2. 2 divided by 2, which is equal to 1. So I don't know if you noticed, but the axis of symmetry is always right in the middle between our two zeros. Oops. Let's not go past that. There we go. Okay. There's that. One more. It's our vertex. So we take our original equation and we plug in our axis of symmetry. So I'm going to throw in my 1. If you want to throw in that 0 at the end for good measure, go for it, but we all know it's 0. 1 squared is 1. That means it's going to be -5 times 1 plus 10 times 1. -5 times 1 is -5 plus 10 times 1 is 10. It's 5. So that means we know it's on the axis of symmetry. It's going to be right here. So that means our parabola looks like this. Whoop. Whoop. Okay. So we've done all the math. We've done all the hard part. That's the hard part right there. That's not too bad. Okay, so now let's go back to the question. I know I started reading it earlier. So a football player kicks the ball off the football tee. The height of the ball, h. So again, think about it. Common sense. My y-axis, height. Right? It goes up. So it's height in meters. After t seconds, so time in seconds, can be modeled using this. What is the maximum height of the ball? So this is what it looks like. Yeah, I'm doing it. Okay, and he's got a football helmet on. Okay, he plays for the Buccaneers. Yeah, with Tom Brady and Gronk. That's his cage, because he's got to be safe even though he's a kicker. And let's get, is there a brown? This is the closest thing. Alrighty. So you ready for this? This is what happens. I'm going to move this. Oops. So this is our y-intercept. Also a 0, which happens. That's okay. Nothing to be worried about. Okay, so what he does is he comes running, kicks the ball, and the ball goes like this. Uh-oh. No, I just want this. Here, what if I go to the inside? What if I just do that part? There we go. And then after he's kicked the ball, it goes, no. No. Did it go through? Let's give him the credit and say it did. I'm sure the ball bounced like this, or it bounced into the stands. Who knows? But that's where it finished. That's where it hit the ground again. That's all we care about. After this, after it goes off, I don't care where it goes. Okay? So, what is the maximum height of the ball? Well, we figured that out. Let's change some colors up. Maximum height of the ball, well, we know it reached this point right here. So it's 5 meters. Make sure you use your units. When does the ball reach the maximum height? We know that was the maximum height. This is my time. 1 second. When does the ball hit the ground? Well, here's the ball. 2 seconds. Perfect. 100%, guys. Way to go. All that work just so we can figure out where that ball landed. Anyways, so I hope that makes sense, guys. Take your time with it. But if you also think about once you've drawn it, because you know you need your x-intercepts and you need your vertex. Once you figure that out, you're probably in pretty good shape and you can find out where everything else is. Okay? Do your practice questions. Let me know if you need any help. Besides that, I won't be posting anything until Friday. And then that'll be it for quadratics. And we will move into triangles next week. Okay, guys? Let me know if you need any help.